In the last segment we posted, we had Jared, he put 4,000 milliliters of gas from this inner tube in and then flamed it from here. We removed that. We don't PVC glue these things in, so it's easy to do the removal. It's a quick removal, brass fitting there. We then take our inner tube. Of course, we're going to make this longer, but we plug that in and open up the valve. And now we're going to do the toothpaste tube. Oops. Yep. Toothpaste tube. Let this thing rise. Oops, lazy. There it goes.
No, that's got to be picked up.
Picked up, huh?
All right, a little bit of a pain.
There's a bit of a pain in it. And this is why inner tubes are not the preferred thing to use, and why on my own porch I have a giant one of these, and I collect my gas directly in the already floating drum. Because
all right, we got a burp. We burp.
Okay, okay. Got a burp. Close the valve. I'll get it. Okay, close the valve. Close that valve. Removal. Alrighty. And
brass fitting.
Brass fitting in. Toggles down.
Toggles down.
Lighter on. This time I'm going to open the valve up very softly. So we have some adjusting here and give ourselves a, whoa, okay, whoops, there we go. Give ourselves a longer burn as it goes down. It is a very safe fuel. Here we're in a relatively unventilated laboratory. There is no carbon monoxide whatsoever from this. There's carbon dioxide and water vapor are the only things coming out of here. And we have the door open. There's enough ventilation. Carbon dioxide is heavier than air. Carbon dioxide would fall to the floor. It would then make its way out the gap underneath the door. The water vapor is water vapor. So it's a very safe thing. So the idea that you can do biogas indoors is probably one of the most exciting things that we're determining here at Mercy College. We do have a propane, methane, and carbon monoxide monitor in the room that would alert us with an alarm if there was any problem. There is no carbon monoxide, so no worry about carbon monoxide poisoning. We don't know yet if we could burn this in an engine to generate electricity indoors without producing carbon monoxide. The suspicion is that it wouldn't. It would still produce just carbon dioxide and water. We're going to test that hypothesis because a lot of people die every year when they're using their emergency generators on a frigid winter's day when it's raining outside, and they bring it in the garage thinking that they can power up their house, and then they end up dying from the carbon monoxide poisoning. Biogas in that same generator as opposed to gasoline could be the solution for that. For victims of Hurricane Sandy and possible future hurricanes, that is good news. But in homes all over the world, in Egypt, in India, in China, people are doing this indoors and they're never having any problems. Unlike propane, which is heavier than air and tends to fall to the ground, it could eventually asphyxiate people or cause an explosion hazard. If there was methane being released that was not being burned, it would go straight up because it's lighter than air and out those vents out the top. So you're really looking at probably the easiest, simplest, and safest solution to solving our energy and waste problems at the same time, just using, in this case, horse manure, and then we're going to start adding kitchen waste to it. But that's that's a nice result, isn't it?
Yes, it is.
It just, and it's a very hot flame, but it's very safe around it. It's that nice blue hot flame, but it's a gas flame, and it's safe. And then, oops, there we go. We're out. And I think I can. Maybe there's just a little bit, a little bit, and then we're definitely out. Okay. Awesome.